Now in this question it says that p of x is mod of x plus whole square minus 6 mod of x minus 1 plus 5, right? And we need to find the distinct points where p of x intersect either x-axis or y-axis. So let us take this expression as y equal to mod of x plus 1 whole square can again be written as x plus 1 whole square. It doesn't matter, right? Because mod of x whole square is as good as x square, because the basic objective is to keep the value positive, and we know that x square will always be positive whether x is positive or negative. And the next thing is minus 6 mod of x minus of 1. So this is mod plus of 5. Now let us first of all find which places it actually intersect the x-axis. So we know that if this is x and y-axis, then any graph which intersect at x-axis, there the value of y is 0, and for y-axis the value of x is 0. So let us take y is equal to 0. So here we'll get that the value of x plus 1 whole square minus 6 mod of x minus 1 plus 5 should be equal to 0. Now here the mod of x minus 1, we need to bifurcate it depending upon whether x minus 1 is greater than 0 or less than 0, right? So take a case 1 when x is greater than 1 or greater than equal to 1. In such case, x minus 1 will always be non-negative. So therein this particular thing can be written as x plus 1 whole square minus 6 times of x minus 1 only, right? Because we know that mod of x is x if x is greater than equal to 0 and minus x if x is less than 0. Fine. So, and the thing is plus 5 is equal to 0. So solving this equation we'll be getting, so it will be x square plus 2x plus 1 minus 6x plus of 6 plus 5 equal to 0. On further simplification we'll be getting it x square minus 4 of x plus 12 equal to 0. Now this is a quadratic equation, so if I want to find the value of x, so first of all let us check whether the discriminant is greater than 0 or not. So discriminant here will be under root of square of minus 4, which is 16 minus 4 times of 12. So here we see that this value will be negative, that means d will be less than 0, hence we will not be getting any real value of x. Fine. Now take the case 2. So in case 2 we will assume that x will be less than 1. In such scenario the mod of x minus 1 will be written as minus of x minus 1, right, with this logic. So here the expression will be x square plus 2x plus 1, and this will be minus minus plus, so it will be plus 6 times of x minus 1 plus of 5 equal to 0. Therein again opening it, so it will be x square and this part will be now 8 of x plus 1 minus 6 and etc. everything will become 0. So this is equal to 0, or we'll get the value as equal to 0. From here we get the two values of x. One is x is equal to 0 and one is x is equal to minus 8. So these are the values of x where the graph or p of x is intersecting at the x-axis. Now let's do the same for y-axis. So for y-axis it is very simple. If the graph is intersecting at y-axis, that means in that case the value of x should be 0. So directly putting the value of x to be 0 at this expression, we'll be getting the corresponding value of y to be, so it will be 1 minus putting the value of x to be 0, it will be minus of 6 plus of 5 or equal to 0. So that means the points in which the graph is intersecting the y-axis is 0, 0, because I took the value of x to be 0 and we got the corresponding value of y to be 0. But here x equal to 0 has already been taken and we have been asked about the distinct points, right? So in this case we can say that this and this are same, correct? So we have only two distinct points. One is, if I graphically make it out, so it will be something like this. One point is minus 8 and the other point is the origin, right? So here I'm not minus 8 0 in fact, so this is 0 because we took y equal to 0. So these are the two distinct points where this particular graph will intersect the x-axis or y-axis. So answer for this question is 2.